Viewers, welcome to very best tutorial. If you are new in this channel, don't forget to hit the subscription button so that you can access our new online classes as soon as we drop them. Okay, today we're going to be explaining redox reaction part 1. This is a full video of redox. It's a full video of redox where we're going to be explaining the meaning of redox and reactions, and then we'll look at the rules that are governing the oxidation numbers of chemical substance, and then we'll look at the different definitions of oxidation and reduction, and then from there we take it to balancing, or take it to reducing and oxidizing agents for this part 1 video. So these are the things we're going to be looking at in this very part 1 video. So first thing first, we're going to start with definition of redox reaction. Very simple. A reaction is said to be redox if oxidation. So we can say a redox. A redox reaction is a type of chemical reaction in which oxidation and reduction occurs together in the same chemical reaction. So you may want to pause the video and get to see. So any reaction in which oxidation and reduction taking place together simultaneously, the reaction is redox. You can see oxidation, that's what we have here, reduction. So any reaction in which a species reduced and at the same time another species oxidizes, is a redox reaction, as simple as that. But you must know in this video the oxidation number of chemical substance are most often uh, obtained by a certain rule. There's a set rule for knowing oxidation number of some chemical substance. So in this video, we're going to be looking at rules that governs oxidation numbers of some chemical species. Not all chemical species, but very few chemical species that we're going to be looking at in this video, or generally. So let's look at the rules governing oxidation states of some chemical species. Okay, so we're going to have the rules here. So we have the rules. So we're going to be having the rules here. We look at this particular species we are talking about. And here will be the oxidation state or number. And then we'll look at the examples. A few examples here. So the rules, I think the rules are 8 or 7 rules that you need to know as far as redox reaction is concerned. So the first rule is species we are looking at is uncombined elements. So if an element is not combined, maybe a free element, a singlet element, a single element, oxidation number of a single element is just 0. So if you go to your periodic table, all the 118 elements in the periodic table all have oxidation number of 0, but the fact that they are just an element. So either is an element, atom, or molecule. Oxidation number of such is said to be 0. For example, I have this H2, okay? I can have this carbon, I can have phosphorus. All the chemical elements, be it molecule or be it an atom, oxidation state of such is 0. That's what we're going to have in rule number 1. So rule number 2, we have combined fluorine. So in most compound of fluorine, very few compounds of fluorine are known, like HF, CAL, fluorspar. So in a combined state like this, oxidation number of fluorine is -1, and that is also with other halogens there in that particular category of halogen. So since fluorine is a halogen, so it's first thing first. In its combined state, its oxidation number is -1. That is rule number 2. So rule number 3, we're going to look at combined oxygen. Combined oxygen, where you see oxygen combined as in water, but as in some of the oxyacid. So in any combined state of oxygen, oxidation state of oxygen is -2. So take note of that. So for rule number 4, you have combined hydrogen, combined hydrogen. Oxidation state of combined hydrogen, like if you say hydrogen in this case, or you see hydrogen in this case of acid. Any compound of hydrogen, oxidation number of hydrogen in any of its combined state or compound is +1. So rule number 5, we have a rule for alkali metals of group 1. So all the group 1 elements are called alkali metals. All the group 1 elements are called alkali metal for the fact that their valence shell electron is just 1. So that should form your own oxidation state, like you can have in lithium, sodium, or potassium. So in their combined state, the oxidation state is +1. Okay, that's for rule number 5. And for rule number 6, we also have alkaline earth metal. These are group 2 of group 2. Oxidation state of these ones, just like their valency, is 2. So for example, the popular element there is beryllium, magnesium, and calcium. So these are for that rule. For rule number 7, okay, this one is going to be charged particle or ion. A charged particle or ions. So when you see a group of atoms that most likely sometimes they carry charge on it, like OH minus, we have CO3, so minus. When you see something like this, so what will be the oxidation state? You see this one is having -1, you see this one is having -2. So and that says equal. So you can say here equal to charge on it. Charge on it. So any charge you see in a particular particle or ion, so what you see on that charge on that particular group of species is going to form its oxidation number. So the last but not the least is rule number 8. Sum of atoms atoms of elements in a compound. That's what complete this is a compound. Okay. Sum of atoms of element in a compound. If you sum all the charges of atom of element in a compound, that should be giving us 0. So we started with 0 and ending with 0. So I'll just give an example of compound. Sum of atom of H2 and O in water. Sum of HF in this compound. Sum of H2 SO. For all the atoms of elements in each individual compound, we also have oxidation number of 0. So these rules are very, very, very important in going further as far as this topic is concerned. So what we're going to be looking at now is in this 8th rule of oxidation number, there are only 2 exceptions that I would like us in this video to understand. 2 exceptions to the rule. There are some species that tend to violate this particular rule. So we're going to look at just only two particular exception to this particular rules that we have here. So out of the 8 rules, there are exceptions.